Hello Godotneers! If you've worked a bit with Godot's way of handling input, you may have noticed that there are a few things which are not as straightforward to do as you might want them to be. For example, we cannot bind some types of input like mouse movement or combinations like left trigger plus A to an action. We cannot easily enable or disable input actions based on the context. For example, if the same input should do different things based on the situation in which the player is in, or if you just want to disable input while you're running a cutscene. We also need to write different code for keyboard input and mouse input, and this makes it kind of difficult to support multiple input devices at the same time. So I sat down and I had a look at how other game engines do this, and I was particularly happy with Unreal's enhanced input system. So I decided to build something similar for Godot, and the result is G.U.I.D.E, the Godot Unified Input Detection Engine. In this video, we'll use G.U.I.D.E to control input for a 3D tower defense game. We'll start with a simple setup where we control the player and the camera with keyboard and mouse. And then we'll add a build mode to our game where the player can build new towers. And both modes use the same controls for different things, so we'll see how G.U.I.D.E's context system can help us to keep our code clean and easy to understand. This is an intermediate level tutorial. To make most out of it, you should already be able to build something with Godot. So you should know the basic features of Godot like nodes, scenes, signals, auto loads, and of course the G.U.I.D.E script programming language. We're also going to focus mostly on the input part with G.U.I.D.E in this video, so this will not be a tutorial on how to build a tower defense game. If you would like to follow along with this video, you can download the example project that we'll use from GitHub. There's a link to this project down in the description. Let's first have a look at our goal. So we want to build a 3D tower defense game, and in the game the player can walk around and shoot at enemies. The player can also switch to a build mode, and in this build mode the camera switches to an overhead perspective, and the player can now place towers to help defending against the enemies. Both modes use these same controls, but depending on the mode, these controls do different things. In walk mode, WASD moves the player, but in build mode, the same keys move the camera. In walk mode, the mouse movement rotates the player and the camera, but in build mode, it is used to place the towers. In walk mode, the left mouse button shoots, while in build mode, it places new towers. And of course, while we are in one mode, we don't want the controls of the other mode to interfere. And we're going to use G.U.I.D.E to handle all of this input in our game. Now, before we can use G.U.I.D.E in our project, we need to install it. G.U.I.D.E is available on the Godot asset library, so we can install it directly from Godot. To do this, we go to the Asset Lib tab and search for G.U.I.D.E. And then we can click on this download button, and this will download G.U.I.D.E and show the installation dialog when the download is complete. G.U.I.D.E ships with quite a few examples, but for this video we really don't need them. So we click up here on this angle bracket icon, and then we uncheck the G.U.I.D.E examples folder. And this will exclude the examples, so we only get the plugin. Now we can click on the install button to install G.U.I.D.E into our project. And after the installation is complete, we need to enable G.U.I.D.E. So we go to the project settings and then to plugins. And here we can see G.U.I.D.E listed as a plugin. And we check the checkbox next to it, close the dialog. And then it's a good idea to restart Godot after we have installed the plugin. Good, now everything is ready and we can start with setting up our player and the camera controls for our game. So how does this work with G.U.I.D.E? Well, like Godot's input system, G.U.I.D.E has a concept of actions. And an action is something that the player can do and that is triggered by any kind of input. We already know a few actions that we want to be able to do. So we want to move the player, we want to rotate the player, we want to rotate the camera, and of course we want to shoot. So let's start with moving the player with the WASD keys. And if we want to build this with Godot's built-in input system, we would now create 4 actions like move forward, move backward, move left, and move right. And then we would map these actions to the WASD keys. But in G.U.I.D.E, a single action can represent all 4 directions. So we create a new action, and to do this, we right-click in our File System Explorer, create, new resource, and now we can search for G.U.I.D.E action. And then we click create, and let's name our action move. We can now click on our action, and this shows it in the inspector. And we have quite a few settings here, but for now, we'll just use this one, which is called action value type. Our movement should be a 3-dimensional vector, so we set this to axis 3D. Well, you may now wonder why we don't use axis 2D, but we'll get to this in a moment. So now we can bind some input to our action, and in G.U.I.D.E this is done with a mapping context. And like an action, a mapping context is a resource, so we again right-click, create, new resource, and then we search for G.U.I.D.E mapping context. And this mapping context will hold all of our input mappings for the walk mode, so let's call it walk mode. Well, let's double click on it, and now Godot will open up the G.U.I.D.E editor for mapping contexts. And if we click this plus icon here, we can create a new action mapping. Now we drag the move action into this empty field here, so G.U.I.D.E knows which action we want to map, and now we can tell G.U.I.D.E which input should trigger this action. This is done with input mappings. We want to bind 4 keys to this action, so we click this plus button 4 times to add 4 input mappings. And to bind a key, we can just click this pen icon here, and this opens up our input configuration dialog. And now we can use the right side to select an input. So you see, we have quite a few options. We have Boolean inputs like button presses. We have 1D input like joystick and mouse axes, and a lot more. We can also let G.U.I.D.E detect an input if we use the left side of this dialog. And this is often a bit quicker than manually configuring it, so we're going to use the left side. We just saw that button presses are Boolean inputs, so let's click here on the Boolean button on the left. And now G.U.I.D.E asks us to actuate the input, which is a fancy word for pressing it, right? So let's press the W key, and it's been detected nicely. Okay, now we can press accept here to use the detected input, and our W key is now bound to the action. Now we can repeat the same process for the A, S, and D keys. Okay, so now we have bound the 4 keys, but how does G.U.I.D.E know which key is for which direction? Well, we need to tell it. If we use Godot's standard transforms for 3D objects, we know that moving forward is -z, moving backward is +z, left is -x, and right is +x. So we need a 3-dimensional input where x is our left and right, and z is our forward and backward. And this is the reason why we have selected axis 3D for our action instead of axis 2D, because we need a 3-dimensional input here. But how does G.U.I.D.E now map our keys to vectors? Well, each input in G.U.I.D.E provides some 3D vector as data. If we look at G.U.I.D.E's documentation, we can see that a key input returns 1, 0, 0 if the selected key is pressed, and 0, 0, 0 otherwise. So if we press W, we get a 1, 0, 0. But when we want to go forward, we need to move into the -z direction. So what we need is a vector of 0, 0, -1, because -z is forward. So how do we get from 1, 0, 0 to 0, 0, -1? Well, G.U.I.D.E can modify any input that it gets with modifiers before our game sees the input. Now let's do this for our W key. So if we click on this plus sign, we can see all the modifiers that come with G.U.I.D.E. We want our input direction to be negative, and the negate modifier can do this for us. So let's add this one. And after the negate modifier is done, our vector is now -1, 0, 0. So we're halfway there, but we still need to swap the x and the z components of the vector. And G.U.I.D.E also has a modifier for this, the input swizzle modifier. So let's add one of these. And to configure the modifier, we can just click on it, and now we can edit the modifier here in the inspector. The modifier has an order property, and this allows us to set the desired order of the vector. We want to swap x and z, so we use the z, y, x order. So now when this modifier is done, our input vector is 0, 0, -1. And this is exactly what we want. All the modifiers are always processed from top to bottom. So the negate modifier is applied first, and then the input swizzle. In our case, it doesn't really matter, but in other cases it might matter. So we can drag these modifiers around with the mouse to change the order. Okay, now that our W key is set up, let's quickly do the other keys. So for A, we want to go left, which is -1, 0, 0. So we add a negate modifier for this. For S, we want to go backwards. This is 0, 0, 1. So we need an input swizzle for this one. And again, we select the Z, Y, X order. So Z and X change their positions. And finally, for D, we want to go right, which is 1, 0, 0. And that is the thing that we get from the input anyway. So we don't need any modifiers for this one. Okay, so now we have 4 inputs with 4 vectors. But how does G.U.I.D.E come up with a single vector from these 4? Well, G.U.I.D.E just adds them up. So if we press W and A at the same time, we get -1, 0, -1, which is exactly what we want. So our inputs are ready and we can use them in the game. So let's have a look at our player. If we open up the player scene, we can see that this is simply a character body 3D with a model of Mr. G and a bit of collision setup. There's also already a script assigned to the player. So let's open the script and we can see that this already has a few things prepared. So we have a variable for the player speed. We have a scene for the magic bolts that we are going to fire later. And a little bit of the movement part is also already implemented. So now we need to access the move action that we have just prepared so our player can use it. A simple way to do this is to just make an export variable for this. So let's add a new export variable named move. And this is a guide action. And if we now save the script, we get a new field here in the inspector, and we can drag our move action into this field. Now we can go to our process function and use this action to move the player. Our player is a character body 3D, and to move a character body 3D, we first set its velocity vector to give it a speed and direction, and then we call move and slide. And the move and slide part is already here, so we only need to calculate the velocity. We want to apply the movement relative to the direction in which the player is looking, so we multiply the basis with our input vector. So velocity equals basis multiplied with move value axis 3D. So this value axis 3D is the vector that G.U.I.D.E has calculated for us with all these modifiers that we have set up. So now we can multiply this again with our movement speed variable that we have up here. And that's it. We have set up G.U.I.D.E so it provides the input in exactly the form that our code needs. So our code can just use it. So let's save this and try it out. We start the game. And when we press the movement keys, well, nothing happens. Why is that? Well, in G.U.I.D.E, we can enable and disable mapping contexts at any time. So we need to tell G.U.I.D.E which mapping context should be active. We don't want to do this in the player because this is more of a global thing. So let's go to our main scene here And at the root of the main scene, we have our world node, and this is a better place to do it. So let's open the script of this node. And to enable a mapping context, we first need to get access to it. And just like with the action, we can make an export variable for this. So let's add a new export variable named walk mode. And this is a guide mapping context. Now we save the script and we get a new export here in our inspector, and we can drag the mapping context into this export. And now we can go to our ready function and enable the mapping context. And to do this, we call guide enable mapping context walk mode. And that's it. So let's save this and try it out. We start the game, and now we can move our player around. Great. So like we just saw, it can quite often happen that things don't work quite as expected. And it would be really nice if we could see which input was detected and how this affects our actions. And because of this, G.U.I.D.E comes with a built-in debug overlay that we can show while the game is running. This is simply a UI element that we can add to our scene. So let's create a new canvas layer where we can put the debugger into. So Control A to add a node, canvas layer, and we name this debug layer. Now let's select a new node, and then we can press this little icon up here to add a scene into our canvas layer. And we search for debug, and there we have the G.U.I.D.E debugger TSCN. And now we can press open and add this to our scene. And if we start the game again, we get some information about what is going on. So down here we have our inputs, and if I press the WASD keys, we can see the input values. And up here we see our move action with the vector that G.U.I.D.E has calculated for us. This debugger will automatically show all the actions and inputs that are currently active, and this can be really helpful when something doesn't work out as expected. Okay, so now we have the movement done. Let's continue with rotating the player. We want to rotate the player with our mouse. And if we use Godot's built-in input system, we now have a problem because mouse movement cannot be bound to actions. So we would now need to detect and handle the whole mouse input in our game code. With G.U.I.D.E, however, all of the input is handled in the same way, and we can actually bind mouse movement to an action. So let's do that. Let's duplicate our move action, and we rename it to rotate player. So we are just going to rotate our player along a single axis. So in the inspector, we can change the action value type from axis 3D to axis 1D. And now we can go to our mapping context and bind the new action that we have just created to some input. So we add an action mapping, and then we drag the rotate player action into this free slot. And now we can add an input mapping and press the pen icon to bind this to some input. At this time, we want a 1D input. So we click on the 1D button, and if we now move the mouse to the left, G.U.I.D.E will automatically detect that we want to use horizontal mouse movement. Okay, let's think about how we would like to use this input in our game. For the movement, we have set up some modifiers so we get the input in exactly the form that we need in our player script. So how should this mouse movement be used in our player script? Well, when we move the mouse, we want to rotate the player around its y-axis by some angle. But our mouse movement input only gives us the amount of pixels that the mouse has moved to the left or the right, and we need to convert this into an angle. And now we could say, well, 500 pixels of mouse movement should rotate the player by a full 360 degrees. Now, the problem with this approach is that our game will now feel differently when we play at different resolutions. If we have a full HD resolutions, then 500 pixel is about a quarter of the screen. But if we play this in 4K, well, then 500 pixels are only 1/8 of the screen. And now we need to move the mouse less than before to turn the player by 360 degrees. So it would be nicer if this would work independently of the screen resolution. And there's a modifier that can help us with this, the window relative modifier. This modifier takes a size in pixels and converts it into window sizes. So let's add this modifier to our input mapping. And now if I move the mouse by half a window width, then this modifier will return a value of 0.5. And let's say we want to rotate the player by 360 degrees whenever the mouse moves by one full window width. And to do this, we can just multiply the value that we got from the modifier with 360. And to do this, we add another modifier, which is the scale modifier. Let's click on it so we can change its configuration. And there is a scale property here. And we can set this to 360 on the X component, and we will leave the Y and Z components at 1 because we're not going to use them anyway. So now our input provides us with an angle in degrees that we can use to rotate the player. Well, let's go to our player script and use this. First, we need to get hold of our rotate player action. So we will need another export variable for this. Well, let's duplicate this one and then call it rotate player. And now we can drag the action into the inspector. Then we can use this action to rotate the player. And this is going to be really easy. We can just change our Y rotation here. So we say rotation degrees, Y plus equals rotate player value axis 1D. And this time we use value axis 1D because we have set up the action to be an axis 1D. And that's it. Let's try it out. So our player looks at the rocks over there. And if I move the mouse over this window from left to right, we can see that while the mouse is moving, the player does one full rotation. And this also works in the other direction. Great. Now, there are two things that we can improve here. So first, the player rotates counterclockwise while I move my mouse to the right. And this is not really how most players would expect this to work, so we should invert this. And secondly, the mouse cursor is visible, which is really distracting. So let's fix the inversion problem first. We can just add a negate modifier to our input mapping. And if we run the game again, now the player rotates in the right direction. Great. Now let's hide the mouse cursor. And this is something that G.U.I.D.E cannot do for us, so we will do it in our main scene script. And here we just add one line to our ready function, input mouse mode equals input mouse mode captured. And this will hide the mouse cursor and keep it in the window. So let's save this and try it out. And now the mouse cursor is gone. Great. Now the player is done, so let's continue with rotating the camera. We want to rotate the camera up and down with the mouse. So let's duplicate our rotate player action here and rename it to rotate camera. This action works pretty much the same way as our rotate player action. So let's open up the mapping context editor. And here we can just duplicate the mapping for rotate player. We get a new entry and we can drag the rotate camera action into this free slot. Now we just need to change the input. So we rotate the camera when we move the mouse up and down instead of left and right. So let's click on the pen icon, then axis 1D, and then we move the mouse up. Well, now G.U.I.D.E has detected mouse up, down, and we can accept this binding. That's it for the setup. We can go to our camera script and use this action. For this game, we have actually two cameras. One is the third-person camera, and the other one is the overhead camera, which we use for the build mode later. We only want to rotate the third-person camera, so let's open up the scene for this third-person camera. And we can see that this is just a simple 3D camera setup with a root node, the spring arm, which is also a pitch node, and the camera itself. So to rotate the camera up and down, all we need to do is to change the angle of the x-axis of this pitch node. We also want this angle to remain between 0 and negative 90 degrees, so the camera doesn't do crazy things. So let's open up the script for the camera. And there's already some code here which makes the camera follow the player, and we just need to add the rotation part. So you already know the drill. We need to access the action. So we make an export variable named rotate camera. This is a guide action. We save this, and now we can drag our rotate camera action into the slot here in the inspector. And now in the process function, we can just add the action value to the rotation of the pitch node. We already have a variable for the pitch node here, so we can use this and type pitch rotation degrees x equals pitch rotation degrees x plus rotate camera value axis 1D. Now, as I said, the angle should stay between 0 and negative 90 degrees. And this is something that G.U.I.D.E cannot know about, so we will need to do this ourselves. So let's use the clamp function. And then we just clamp this right expression here between negative 90 and 0. So let's try this out. We start the game. And now we can rotate the camera up and down and walk around. Great! So now we come to the fun part in walk mode, which is shooting. So let's duplicate the rotate camera action and name it shoot. And in the inspector for our new shoot action, we set the value type to bool because, you can either shoot or not shoot. So now in our mapping context, we add a new line and maybe close some of these lines up here so we have a bit more room. We can drag the shoot action in, and then we add an input mapping, press the pen icon, and this time we want a Boolean input. So we click on the Boolean button and we press the left mouse button, and then we click accept. So that's our action. Let's use it in the player script. And this is pretty much the same deal. We already know we add an export variable named shoot, and this is a guide action. And now we can drag the action into the inspector and go to our process function and use this action to shoot. There's already a function down here called fire magic bolt, which does the actual shooting. So we only need to call this function when the player should shoot. So we can add an if statement. So if shoot value bool, then we call fire magic bolt. Well, let's try this in the game. And it shoots, but it shoots the bolt every frame for as long as we press the mouse button. But we actually only want to shoot our bolt once for each button click. So how can we do this in G.U.I.D.E? Well, G.U.I.D.E has a concept named triggers. Well, let's go back to the mapping context. And we see that there is another column here on the right-hand side where we can add triggers. A trigger is something we add to an action, and this trigger will look at the input value and then decide whether or not the action triggers. Let's click on the plus sign and see what kind of triggers we can use. And there are quite a few options here. For example, the down trigger will fire whenever the input is currently down. The hold trigger will fire if the input is held down for a certain amount of time, and so on. If you're not sure which trigger to pick, there's a page in G.U.I.D.E.'s documentation that describes all the built-in triggers and how they work. We cannot go through every trigger in this video, so we will just pick the one that we need right now, which is the pressed trigger. This trigger will trigger the action once the input is actuated, and it will not fire again until we have released the input. So this is the same thing that Godot's isActionJustPressed function does. So now our action has a pressed trigger. Let's see if this fixes the problem. We run the game. And this doesn't seem to do anything at all. Why is that? Well, the value of an action and its trigger state are two separate things. If we look at the first frame after an action is triggered, we can see that the trigger state for our action is triggered and its value is true. And in the following frames, this action value stays true because the input is still actuated. But our press trigger doesn't trigger anymore, so the action's trigger state goes from triggered to completed. Now in our code, we just check for the action value and not whether the action is currently triggered. So how can we check if the action is triggered? Well, there are multiple ways to do this. Every guide action has an isTriggered function that can tell us if the action is currently triggered. So we can change our if statement here to if shoot is triggered. And now if we run the game again, we can shoot our bolts once when we press the mouse button, and they will not fire again until we release the mouse button. Great. There's also another way to do this. Guide actions emit a signal when they are triggered, and we can connect to this signal. So instead of checking whether the action is triggered every frame in our process function, we can connect to the triggered signal of this action. Well, let's do this. We delete this if statement here. And then in our ready function, let's connect a signal. So we write shoot, triggered, connect, fire magic bolt. So whenever the shoot action is triggered, the fire magic bolt function is called. Well, let's try this out. And this still works nicely. So now we have the walking and shooting pretty much done. So let's start implementing the build mode where the player can build new towers to defend against incoming enemies. So when the player activates build mode, we want to switch to an overhead camera. And now the player can press a button to start placing a new tower, and then the player can use the mouse to find a good position and press the left mouse button to place the new tower. The player should also be able to move the overhead camera with the WASD keys. Now, as I said in the beginning, our build mode uses the same keys and mouse input as our walk mode, but it will run different actions with this input. And this is something that is rather difficult to do with Godot's built-in input system, especially when we have more than one place in our code where we check for input. But with G.U.I.D.E, there's a simple way to do this. We can just create a second mapping context that is independent of the first one. So let's create a new mapping context and we call this build mode. And because our input resources down here are getting a bit cluttered, let's reorganize them a bit. Let's create a new folder named input. And in this folder, we create a subfolder for the walk mode. And we can drag our walk mode mapping context and all the actions that belong to it into this folder. And now we can add a second folder called build mode, and we drag the build mode mapping context that we have just created into this folder. Okay, now we are a bit more organized and we can start setting up the input for the build node. Let's start with two new actions which allow us to switch from walk mode to build mode and then back to walk mode. So we duplicate this shoot action here and we rename it to switch to build mode. And then we make another duplicate and name it switch to walk mode. And then we drag this action over into our build mode folder because this is only relevant when we are in build mode. Good. Now we need to map these actions to input. We start with the switch to build mode action, and we can only switch to build mode while we are in walk mode. So let's open up the walk mode mapping context and add a new mapping. We drag the switch to build mode action in, and let's bind this to the Q key. Let's also add a pressed trigger so that we only trigger this action once and not every frame. So now when we are in build mode, we of course want to have a way to go back to walk mode. So we need another mapping that brings us back from build mode to walk mode. So let's open up the build mode mapping context, add a new mapping, and then we drag in the switch to walk mode action. And we also bind this to the Q key and we add a pressed trigger. So now the player can press Q to basically toggle between the two modes. We still need to implement the actual switching though, and I think a good place to do this is our main game script here at the top of our main screen, because the player shouldn't really be concerned about these modes. So I think it is a good idea to make one function for switching to each mode. So let's create a new function, switch to build mode. And this is empty for now. And a second one, switch to walk mode, which we will also leave empty for now. Now we need access to our new build mode mapping context so we can switch to it. And of course, we also need access to the switch actions. So let's duplicate this line for the walk mode mapping context and rename this build mode. And then we add a new export var switch to build mode, which is a guide action. And we duplicate this again and rename it to switch to walk mode. Okay, let's save this. And now we can drag in the mapping context and our two new actions into the inspector. Great, so now we have everything and we can listen to the actions triggered signals to call the functions that we have just created. So here in our ready function, we add two lines. When the player triggers the switch to build mode action, we call switch to build mode. And when the player triggers the switch to walk mode action, we want to call switch to walk mode. Great, so now we can implement the switching functions. Now let's start with switch to build mode. First we need to disable the current mapping context, and we can do this with guide disable mapping context walk mode. Now our walk mode controls will no longer work, and next we need to enable the build mode mapping context. Next is switching the cameras. And up here, there are already some on-ready variables which pull in the two camera nodes that we have in our scene. So we can just change which of these cameras is currently active. We want the overhead camera to be active, so we set overhead camera active to true. And we want the third-person camera to be inactive, so we set third-person camera active to false. Next, we want to show our build mode user interface, and there's also an onReady variable for this. And the script for this user interface also has an active property, so we can add another line down here, build mode UI active equals true. Finally, we want to show the mouse cursor, so we set input mouse mode to mouse mode visible. And now we can copy all of this and paste it into the switch walk mode function. And then we just need to make a few changes. We disable the build mode. We enable the walk mode. We set the third person camera to active, the overhead camera to inactive. We hide the build mode UI, and we also hide the mouse cursor. And we can just move this line up here that we have in our ready function to do this. Now, when the game starts, we want to begin in walk mode. So in our ready function, we just call switch to walk mode. Okay, that was a lot of stuff. So let's try this out. And we start in walk mode where we can walk around. And now if I press Q, the overhead camera becomes active and we can see our build mode UI. And if I now use the WASD keys or click the left mouse button, then nothing happens anymore because in build mode, these inputs are not mapped to any actions. So let's press Q again and we're back in walk mode. And our player also moves again. So that worked nicely. And we can now implement the camera movement in build mode. Let's have a look at our overhead camera. This has its own scene and it's built up a little bit differently than the third person camera. We have a root node here, which automatically follows the player. And then we have an offset node, which keeps the camera above the ground. And we'll use this offset node for our camera panning. So when the player presses the WASD keys, then this node should move forward, backward, left and right. And this way the camera pans and shows a different part of our game scene. If we look at the setup, we can see that this camera movement pretty much works the same way as our player movement in walk mode. And we already know how to do all this. So let's duplicate the move action and rename the copy move camera and drag it over to our build mode folder. And next we can open up our build mode mapping context, add a new mapping, drag in the move camera action, and then we bind this to the WASD keys. The binding is exactly the same as for the player movement, so it uses the same inputs and the same modifiers. And now we only need to implement this in our overhead camera script, so let's open up the script. And first, we of course need an export for our action. So export var move camera. This is a guide action. And now we can drag our action into the inspector. And then we can go to our process function and use this action to move the offset node. For moving, we need access to the offset node. And there's already an onReady variable for this node up here. Now, because this is just a simple node 3D, we don't need any move and slide. We can just change its position. And like for the player, we want to take the node's rotation into account when moving the player. So offset position plus equals offset basis multiplied with move camera value axis 3D. Now all we need to add is the movement speed. And the camera already has an export for this up here. So we multiply this movement speed with the direction that we have just calculated. And because our speed up here is given per second and not per frame, we need to multiply all of this with delta. And that's it. Let's try this out. And now we can move the camera around with the WASD keys. Great. So now we have the build mode set up and our camera is working. So let's add the ability to place towers. And if we look at our build mode UI, we can see that there is already an icon with a 1 below it. So when the player presses the 1 key on the keyboard, we want to start placing a tower. And then the tower should follow the mouse cursor in our 3D world. And when the player clicks the left mouse button, the tower should be placed if it is at a good location right now. And we also want to abort the placement when the player presses the right mouse button. So we need 3 new actions. First, to select the tower. Second, to place the tower. And third, to cancel the tower placement. So now we can open up our build mode mapping context and add bindings for these actions. And they work pretty much the same as our switch to walk mode action here, just with a different input. So let's duplicate the mapping, drag in our select tower action, and change the binding to the 1 key. Now we can do the same thing for the place tower and our cancel tower placement actions. So there's one more thing that we're going to need, and this is the current mouse position. And we really don't want to call get global mouse position in our code, because then the whole input abstraction is just out of the window. But G.U.I.D.E has a built-in input that can give us the current mouse position, and we can actually bind this to an action like everything else. So let's create a new action, and let's call this action tower position. The mouse position is a 2D vector, so we change its value to axis 2D. And now we can bind this in our build mode mapping context. We add a new mapping, we drag in the tower position action, and then let's click the pen icon to bind it to the mouse position input. G.U.I.D.E cannot detect this input automatically, so we need to select it here on the right-hand side of the dialog. So we go to the 2D section, and there we have mouse position. And we can just click on this to bind it. Now we have all the input that we need to place the towers, so let's actually implement this. And let's first get an idea on how this is going to work. Here in the main scene, we see our build mode UI node. And when we select a tower, then this UI needs to create a new tower that follows the mouse position. And we already have a tower scene here in our project. So let's drag this in and have a look at it. We have the tower in the middle and we have some placement aids. So the blue circle is the area where the tower will be detecting enemies. And the red circle is the area where no other towers can be placed. And these circles are only visible while the player is deciding where the tower should go. In the tower script, we already have code that can put the tower into a placement mode. And in this placement mode, the tower will not fire and it will make sure that we can see the placement aids that we just saw. There's also a function that checks if the tower can be placed at the current position. Now, back to our main scene. So once the tower is at a good location and the player presses the left mouse button, we want to place the tower. And the tower should end up as a sibling of our build mode UI, like this one tower that I just added. So that's a lot of stuff to do, so let's get going. We delete this example tower and now we can go to our build mode UI. And there's also some code here as well. We have code to activate and deactivate the UI. And we already have an export for our tower scene. So let's add some exports for the actions that we need. We need the action to select a tower, the action to place a tower, the action to cancel the tower placement, and the action with the current mouse position. So let's drag these actions into the inspector and we're good to go. Now we can start with selecting the tower. We'll just add a new function that handles this. So func select tower. And we leave this empty for now. And in our ready function, we connect this function to the trigger signal of our select tower action. So whenever the select tower is triggered, we want to call this select tower function. So when the player selects the tower, we want to create a new instance of our tower scene and place it in the world and make it follow the mouse cursor. So let's first create a new tower instance. So var tower instance, this is tower scene instantiate, and we add it to the world. So get parent, add child, tower instance. We also want to activate placement mode, so we can see the placement aids and the tower will not fire at the enemies while it's being placed. So tower instance placement mode is true. Now to make the tower follow the mouse, we need to have access to this tower down here in our process function. So we need to make this tower instance a member variable of our script. So we add a new variable up here, var current tower. This is a tower. And then we assign the tower instance to this variable. And we fix up these other lines where we use the variable. We should probably also add a check that if we already have the tower selected, we don't want to create a new one. So if current tower is not null, then we return. Now we want to move this tower in our process function so it follows the mouse. There's a small problem though. Our tower is a 3D object and it should move in the 3D world. But our mouse cursor is a 2D position on the screen. So we need to convert this 2D position into a 3D position. And one way to do this is to make a so-called raycast. When we do a raycast, we shoot a ray from the camera through the mouse cursor into our world, and then we see where this ray hits. And the position where this ray hits the world is the position where we want to put our tower. But the tower should only go on the ground, so the player should not be able to place a tower on these rocks or these trees or the player or this building. It should only go on the ground. So we need to make sure that our ray ignores everything but the ground. And we can do this with Godot's physics layers, so let's go to our main scene. And if I select the ground, we can see that the ground is in layer 1 and in layer 5. the player, the rocks, the enemies, they are also in layer 1, so they can collide with each other. But layer 5 is only used by the ground. So if we limit our raycast to layer 5, we will only hit the ground and nothing else. Okay, so now we would need to do a raycast and some mathematics to convert a 2D position into a 3D position. But actually, G.U.I.D.E has a built-in modifier that can do this for us. So let's go back to our mapping context. And here we add a 3D coordinates modifier to our tower position action mapping. And if we click on the modifier, we can set the layer mask that should be used for the raycast. So we set this to 5 because we only want to hit the ground, and that's it. The only other thing that we need to do is to change the value type of our tower position into axis 3D, because this action now provides us with a 3D position instead of a 2D position. So let's go back to our code, and in the process function, we check if the tower is currently selected. So if current tower is not null. And then we just say current tower, global position. This is tower position, value axis 3D. Okay, let's give this a try. We press Q to enter build mode. We press 1 to select the tower. And now we can see the tower following our mouse cursor, just like that, with a single line of code. So this is great, but we also would like to give the player some visual feedback on whether or not the tower can be placed at the current location. And for this, there's already a label here in our scene that we can use. So if I make this visible, we can see that it reads location is blocked. So we want to make this label visible when the tower cannot be placed, and we want it to be invisible when the tower can be placed. When we look at the top of our script, there is already an onReady variable for this, so we can just use this in our process function. When we looked at the tower script earlier, we saw that the tower has a function that tells us if the tower can be placed at the current location. So all we need to do is call this function and then show or hide our label. So blocked label visible is not current tower is location clear. So the label will only be visible if the location is not clear. So let's try this out. We press Q to enter build mode. We press 1 to select the tower. And now if I move the tower here into the rocks or over this tree, then the label becomes visible. It would be really nice though if the label was at the mouse position so the player can see it better. And well, I guess you know where this is going. We can add another action that can give us the mouse position in canvas coordinates. So let's duplicate our tower position action and rename it to tower position 2D. And we change the value type to axis 2D because this is now a 2D position. And now we can go to our mapping context, duplicate the mapping for tower position, drag in our tower position 2D action, and then we delete this 3D coordinates modifier and instead add a canvas coordinates modifier. And this modifier will give us 2D canvas coordinates for the current mouse position. And it will also take any scaling or 2D camera offsets into account. So if you use this in a 2D game, it will just work. So now we can go back to our build mode UI script and use this new action to position our label. So first we need to get hold of the action. So let's duplicate this line for the tower position action and rename it tower position 2D. And then we drag this action into the inspector and we can use it in our process function to position the label. So blocked label, global position is tower position 2D, value axis 2D. And that's all we need to do. Let's try this out. We press Q to enter build mode, press 1 to select the tower, and now we can see the label following the mouse cursor. Great. So now the only thing that is missing are the two actions to place the tower and to cancel the tower placement. Now let's start with creating two new functions for these. So we make a new function place tower. And at the beginning, we have to check if we have a tower. So if current tower is not null, and we can only place a tower when the location is clear. So, and current tower is location clear. And if this is the case, we want to deactivate placement mode. Current tower placement mode is false. And we set the current tower to null. So this will effectively just leave the tower in the world at the current position. We also emit a signal so that our game knows that we just placed the tower. This signal is used by the game to rebuild the navigation mesh so the enemies can find their way around the new tower. But this video is all about input, so we're not going to get into the details on how this works. Now we add another function to cancel the tower placement. So func cancel tower placement. And again, we check if we have a tower selected. And if this is the case, we remove the tower from the world. So current tower queue free. We also set the current tower to null. And we need to hide the label because it could still be visible right now. So blocked label visible is false. And now we just need to call these functions whenever the actions are triggered. So in our ready function, we need to add two more lines. So when the place tower action is triggered, we want to call the place tower function. And if the cancel tower placement is triggered, we want to call the cancel tower placement function. And that should do the trick. So let's give it a try and see if it works. We press Q to enter build mode. We press 1 to select the tower. And now we can move the tower around. And if we press the left mouse button, the tower is placed. Now let's press 1 again to make another tower. And if we press the right mouse button, then the tower goes away. Nice. In this video, we had a look at G.U.I.D.E, a new library that helps us to simplify the handling of input. We learned that G.U.I.D.E uses actions as an abstraction layer between the input and our game code. We learned that actions have a value, which can be a Boolean, a single float, a 2D, or even a 3D vector. We learned that G.U.I.D.E represents all input as a 3D vector and that we can use modifiers to bring the input into exactly the form that we need in our game code. We also learned that actions can be triggered when their input changes, and we learned how to use triggers like the press trigger to only run game code once when a key is pressed down. We learned that G.U.I.D.E uses mapping contexts to group actions and that we can enable and disable these mapping contexts to switch between different input setups. There's actually a lot more that G.U.I.D.E can do, so there will be a second video where we will add controller support to our game, check out how we can show input prompts to the player, and how to build a simple input configuration menu where the player can rebind the keys and configure things like input sensitivity. I hope this video has been helpful. If you have any questions or suggestions on how G.U.I.D.E could be improved, please post them in the comments. If you liked this video, please give it a thumbs up and consider subscribing to the channel to get notified when new videos are posted. Thank you very much and happy Godotneering!